My name is Fabio. I'm part of the Xerox team. And today we're going to be doing a workshop on one of our most exciting projects at the moment called Xerox Mesh. It's a peer-to-peer network for sharing DEX orders. Just a little bit of an overview of the presentation and then the workshop. We're going to start with just a little bit of background on Xerox and also explain why we're building Mesh, what problem does it solve. Then we'll go into Mesh, what is it, how does it work, go into some use cases for Mesh, the tech stack that we're building on top of, talk about one of the features that we're really excited about, which is browser support, so actually having the node run in a browser tab. And then we'll go and actually together spin up a Mesh node, connect to it, connect to an order stream, fetch orders from the network, post an order to the network, and actually use it. Cool, so just a little bit of background on Xerox. Xerox is a decentralized exchange protocol. What we mean by protocol is that anyone who's building an exchange on top of Xerox, all they need to do is have the orders in their order books conform to the Xerox order message format. So once they do this, they can then use this single shared audited set of smart contracts to perform settlement. And there's a whole bunch of developer tools that they can use to both interface with the smart contracts, UI kits for building a DEX UI, and of course, Mesh. So since we've launched, we've helped exchange a lot of value, and we have a bunch of projects that are building on top of us. So it's quite exciting. Cool. So unlike other decentralized exchanges, Xerox is not an automated market maker. That's like Uniswap, Bancor, and it's also not fully on-chain like ETH to DAI or Oasis. So the way that Xerox works is that the orders are created and shared off-chain, and then they are only sent on-chain for settlement. So this actually lets you update your orders more frequently. It lowers the gas cost of trading because you don't need to do a transaction to create an order or to update an order. And we're storing the least amount of information possible on-chain. It also enables these order book style markets. So these are markets that are similar to traditional financial markets where you have a bunch of bids and a bunch of asks on a book, and they're constantly being updated by the makers of those orders. And I guess our bet at Xerox is that this order book style market is actually going to outcompete the other models. Specifically, when we compare it to automated market makers, both it can support larger buys with lower slippage, which is really nice, and it doesn't rely on arbitrage to keep the price on a particular book in line with the rest of the market. Cool. So, all right, Xerox, it's this protocol. You can use it. It gives you settlement. It gives you tools. But it doesn't specify how orders are stored and shared off-chain. And right now, most orders are stored on relayers. And a relayer is simply anyone who hosts a database of orders and helps counterparties find each other. But the question, so all relayers that are built on Xerox, again, they have the same order message format. So what that means is you could take an order from one relayer and you could actually fill it on another. And why would they want to share liquidity in this way? Because that way they can actually have deeper books and better prices for their customers. But how should relayers share liquidity? This is a big question. And obviously the naive implementation would be every relayer just connects to the API of every other relayer. And like that they can pull all the orders. But the problem with that is that every single integration is custom, takes a lot of engineering effort. And if there's a new relayer that pops up, he has to go to every single other relayer and be like, hey, add me, I exist. So this was actually one of the big reasons why we decided to build Mesh. We just realized that it wasn't as easy as it should be to share orders. So Mesh, Xerox Mesh, it's a gossip-style peer-to-peer network for sharing Xerox orders. You can kind of think of it like BitTorrent, but instead of downloading music and movies, you're downloading cryptographic commitments to buy or sell a given asset. The data on Mesh is obviously also less persistent than on BitTorrent. So orders, they become invalid, they get canceled, they get filled, and so they're constantly revalidating all these orders and then removing the ones that are no longer fillable. So Mesh uses the Ethereum network for two purposes. The first is obviously to validate the 0x orders, make sure that they're still fillable. The other is actually to protect against some resource exhaustion attacks. So what we do is we actually link a scarce asset that exists on the Ethereum blockchain to the scarce resources that exist in the network. And in so doing, we can prevent someone from DDoSing this peer-to-peer network and just flooding it with a bunch of random orders. So what are some of the benefits of Mesh? It's a completely decentralized off-chain order propagation mechanism. Up until now, you kind of had to use a relayer. You had to rely on some third party to host your orders. You don't anymore. You can just spin up a node and join this network and start propagating orders. The second is this concept of shared liquidity. This is something that doesn't really have a parallel to centralized exchanges. Literally being able to just seamlessly discover any order that exists out there and also share any order that you want with everyone else. And so, this liquidity can kind of show up on a bunch of different surfaces over the internet. If you're an entrepreneur and you are building a DeFi application and you need liquidity, you can just spin up a Mesh node and tap into it. And the last one is market formation. So, you have your project, you have your core kind of supporters and early adopters, but how do they start trading this new asset that you've created? Until now, it's been mostly you have to pay a listing fee to Binance, you have to try and get it onto a centralized exchange, but now you can actually have your users trade over a neutral, permissionless network. Cool, so let's go into some use cases. Let's say you want to build a DEX. What you can do is you can actually pull liquidity from Mesh and solve this chicken and egg problem that exists when you're bootstrapping a two-sided market and already have a bunch of orders on your book even before you launch. So when a user comes to your site, they're not confronted with a deserted UI with no orders. Instead, they see this bustling UI and they're much more likely to stick around. Let's say you want to create a new asset. Instead of listing yourself on Binance or something like that, why don't you list yourself? And so with Mesh, it's very easy for you to create some orders that your early adopters can take, and you can spin up this open source DEX UI and host your own exchange. This is actually an example of a project called VeriSafe that did exactly that. What if you're market making? Mesh, it's really nice because Mesh actually combines all of these different exchanges and relayers into a single format. And so if you're a market maker, you can just plug into Mesh, push your orders into Mesh, and they will surface on all of the relayers. So instead of posting directly to a specific relayer, you can just post it into Mesh. All the relayers will get it. And even if a new relayer or DeFi application comes into existence, your orders will already be discoverable by them. So there's another really interesting aspect of Mesh for market makers in particular, and that's that without Mesh, you've always had this exchange which gets to decide what are the market mechanics and what are the rules under which you will trade with traders. And typically this is either an order book style exchange or something like that, but it doesn't let market makers innovate and kind of try and outcompete each other by using different strategies. With Mesh, though, market makers can connect directly to traders. And so what we're seeing is market makers starting to innovate in how they deliver orders. So some examples are market makers that want to create a request for quote system where, kind of, I guess similar to AirSwap, you have this back and forth where you're deciding on a price. And depending on who the counterparty is, the market maker might give a better or worse price. Another example is just price matching Binance. So what you can do is say, I will give you the price on Binance at the point of settlement. And they craft their order such that it probably has a worse price than Binance. They'll fill that and refund you the difference. I think there's going to be a ton of innovation in this space. And then lastly, what if you just want to trade the newest, coolest experimental assets that aren't listed anywhere yet, right? Like imagine a project with 111 people, maybe it's called StableCat, it's launching a new stablecoin that's backed by CryptoKitties, super wow. And this actually goes a little bit into the browser support that I'm going to talk about later. But what StableCat can do now with Mesh is they can host an open source DEX UI on IPFS and actually have Mesh running in the browser such that all of their early adopters get connected to one another and can start trading. And this is kind of how a market can start to form. So what is Mesh built with? Mesh is written in Golang. It compiles down to WASM. We use libp2p for a lot of the networking stack, specifically GossipSub, Kademlia DHT, AutoNat, and PeerStore. For the persistence layer, we're using LevelDB. And we use Go Ethereum to interface with the Ethereum blockchain. So now a little bit more about browser support. Not a lot of peer-to-peer networks work in the browser. And there's several reasons for that. But we're very excited about offering this as a feature because we think that it drastically lowers the barrier to entry for someone to get connected to the network. Just opening up a tab is much easier than downloading software, running a node, going to the console, etc. So how are we achieving this? We compile to WASM. Luckily, libp2p does too. Obviously, we have to think about the database layer. How is that going to work in both browser and non-browser environments? We found a way to get LevelDB to work in both, and that is by actually shimming the file system calls in the browser to using browser.fs. And browser.fs actually lets you decide if you want to store to local storage or to IndexedDB under the hood. For libp2p, the PeerStore module is actually stateful, so it stores this information to disk, but it can be configured to use LevelDB. And then probably the most important part is supporting multiple transports. So TCP only works non-browser to non-browser. WebSocket can handle browser to non-browser. And WebRTC is pretty much the only protocol that I know of that supports browser-to-browser communication. So that literally means that there is no server between two browser tabs. They're connected directly to one another. Right now, libp2p has a transport called WebRTC Direct. It actually only supports browser to non-browser connections, and that's because browser tabs, you can't open up a socket to a browser tab. There's no way to ping or dial a browser tab. So the WebRTC connection actually needs to get bootstrapped. And we're currently working on a specification to do that using a third node in the network. And so yeah, we're super close. There's actually one more PR out to get to MVP browser support. And then by the end of next month, we're planning to have it completely finished and ready to go. Cool. So that was kind of the introduction part, a little bit about Mesh. Now we're going to dive into actually spinning up a Mesh node. Let's actually let's connect to the order stream. Let's get some orders. So what I did just to make it easier for you guys is I created these bit.ly links. And this one goes to just a gist on GitHub that actually has an Ethereum RPC endpoint already in there that we can use for the demo. And you can literally, all you need to have installed on your computer is Docker. So as long as you have Docker running, you should be able to then just copy paste this snippet and start running the node. And I'm going to do that here. Cool. So here is literally that same command. So let's just start the node here. Cool. So what we can see here is it's saying found peer who speaks our protocol. So those are all other mesh nodes in the network. And now it's going to start connecting to those mesh nodes. Sorry, I'll go back to here in case anyone still needs the link. And then I guess the other thing that I wanted to just point out here is that 60557, that's the JSON RPC port. So this is, I guess 8545 is typically what it is for an Ethereum node. For us, it's 60557. And then 60558, that's actually the port that's used for the peer-to-peer networking. Yeah, you were specifying an Ethereum network ID and an RPC URL, and that's pretty much it. Yeah. Yeah, I can do that. Make this bigger? Yeah, let me know. We'll be like, where is everyone in the process? Yeah, good. Is anyone else still getting their node up and running? Or okay, cool. So we have our node up, which is exciting. So now we're going to connect to our mesh node using the JSON RPC interface. And we have an official TypeScript client and a Go client, but you can also just use any JSON RPC client. And for this demo, we're going to use the TypeScript client. So I created this repo called Mesh Workshop Demo, and it's literally just a couple scripts that instantiate a client and then runs a certain method on it. And yeah, if you just go to that bit.ly link, it'll send you to this, and you can clone the repo, and the instructions are in the README. But let's maybe go to the first call. So the first call that we'll do is get stats. And this just gets you a bunch of statistics about your mesh node. So here you can see we just import the RPC client. We instantiate it, pointing it to localhost 60557. We call get stats, and we just print it out. So if I run this here locally, oh, well, the law of demos. Great. So let's see what's going on. Okay. Okay, the method handler crashed. That's not good. Okay, I might try and spin this up again. Oh wow. Okay, hang on. Sorry. I think I might. I was using the wrong. API key for Alchemy. So now we need to wait for the node to boot up. Okay, it's connecting to certain peers. So if we call get stats now, we'll see some statistics about the node. So here you can see, what pub subtopic is it listening to? What's its peer ID? What's the latest block that it's processed? The number of peers that it's connected to, and the number of orders. And since we just started the mesh node, it doesn't have any orders yet. We can call it again. Cool. So we already have 220 orders that it pulled from the network, and that number will go up as it warms up. Cool. So let's see. That's the get stats endpoint. Now let's do something more exciting. Let's actually connect to the order stream. So the order stream is interesting. It's not just a stream of, hey, these are orders that have been found in the network. It's also, it also has events for whenever the state of that order changes. So if the order expires, if it gets filled, if it gets canceled, all of that you will receive for orders that you've previously seen. And let's see, so here we'll do the order stream. Cool. So here we can see these order events coming in. It's a little bit hard to read, but what we have here is the order, and then we also have, let's see, it's hard to see here. Oh, the kind, and the kind, oh yeah, here. Kind says expired or added or filled. And so whenever the state of the order changes, we get a notification. Yeah. Maybe I can pull it out. Oh. Is that better? Yeah. Cool. Yeah, so here is the stream of orders that are being found on the network, and then also when they expire or filled, we get a notification. Cool. So that's the order stream, and we'll get into this maybe a little bit later. But you can then pipe that order stream into whatever database you want. So what if you just want to get all the orders that are currently sitting in your mesh node? There's a function to do that as well. Just get orders async, and if we do that. I think I think what I did here is instead of printing them out, because it would be quite a lot, it'll just say how many orders it found, which in this case now is 456. So now let's add an order. So if we want to post an order to the network, this is what an order looks like. It's literally just a JSON object or a JSON blob. It has all the fields. So what are the assets that are being traded? At what is the price? What's the expiration? Here's a signature. The signature, can be just like a regular EC signature, or it could be something more elaborate. And what you can do then is just take this order and pass it to add orders async. And this actually, it takes an array, so you can send multiple in one go. And I'm pretty sure I already added this one to the network, so I wouldn't be surprised if we get an error instead of a success, but let's see. Accepted. Okay, cool. Nice. So here we can see I just submitted this order to the network. It was accepted. This is how much of the order is still remaining to be filled, obviously in base units, kind of like in way, I guess, and the order hash, etc. If it was rejected, we would see it in this array, and it would have a reason for why it was rejected. Cool. So what if you want to perform more advanced queries? Oh. No, so I created this order already ahead of time and signed it. So this signature is essentially signing all of this information. And that way, no one can change the information without having the signature change. Yeah. So I didn't actually show the part of creating the 0x order. But we also have libraries that will help you do that. So what if you want to do more advanced queries? Our JSON RPC interface, it doesn't have a very expressive kind of querying language, and a large part of that is that the underlying DB, level DB, we've been optimizing it more for running the mesh node and not necessarily for kind of querying order books, etc. So the way that we envision people doing that is actually syncing mesh with an external database of their choice. So you could sync it with a Postgres database if you want to use SQL for querying. You could sync it with a GraphQL database if that's how you like to kind of look at your data. And we have on our documentation, we have a step-by-step kind of instruction guide going through how you do that. We also have already done it, and that link up there will take you to it. We have another project called LaunchKit. It's essentially both a DEX front end and also a DEX back end. The back end, we've taken it and we've added mesh to it. So now you can easily spin up a mesh node that also has an HTTP and WebSocket interface that lets you query orders, and it will give you these methods. So get asset pairs, get orders, order, and these also have obviously query parameters where you can say, I want all the orders that are ETH to DAI. I want to get all the orders that are on a certain book. Yeah, but we hope that other people will create other kind of mashups between mesh and some database and some querying language that people can use.
Quick question.
Yeah.
You run this completely in the browser, and you propagate or gossip your order.
Mm-hmm.
It still has to go to some relay to then actually send on chain, right?
No, it doesn't. So anyone can take that order from the mesh node and submit it directly to the Ethereum blockchain.
Okay, so then you need like MetaMask.
Yes, yes, exactly. So in order to send the transaction,
Usually, I'm not going direct, but
yep.
I thought you like sign your order and then the relay submits it for you, right?
So there's different models. There's models where the taker submits it, and there are other models where the relayer submits it. If it's, we call the one where the relayer submits it the matching model. If it's a matching model, then yes, you have to send it back to the relayer. But if it's an open order book model or an open order book order, then anyone can submit it.
Okay, then you run into risk of like having racing conditions if you have various interfaces and you have to submit an order and then two people want to fill the same one.
Yes, yes, yes. So that's like trade collisions. That's an issue if you're doing open order book. There's a third model that we've been working on called the coordinator model, and there you go to a coordinator and you say, I want to fill this order, and they will give you a signature to allow you to fill it. And so they can only give you the signature and not someone else so that there isn't a race condition. They just return to you a signature that lets you submit it on chain. Yeah, because we have this, so the 0x smart contracts are highly extensible, so you can add whatever logic you want in front of an order filler. Yes, exactly, yeah. Cool, so if you do use Kit backend with mesh, you kind of get this bonus because you can use the DEX front ends. So this is an open source front end that we built that anyone can use. It's, it talks to an SRA endpoint. And so, yeah, you can essentially have all your mesh orders show up on a DEX UI, or you can also have them show up in a collectibles UI. So 0x also supports NFTs. So if you want to create a marketplace or kind of like more of an eBay style market, you can do that as well.
Where we can find it? Is it somewhere in the documentation?
Yeah, so it's on GitHub, and it's called Launch Kit. So if you just do GitHub 0x Launch Kit, you'll see it. Cool. So I also just wanted to show the browser interface. So if you're using Mesh in the browser, you actually import a different package. It's called Mesh Browser. And it's similar to the other interface, except obviously, we're passing in the configs here as a parameter. And then, you can start the mesh node, and you can also listen to order events. So this is how you would use it in the browser. You would obviously not be using the command line, and you wouldn't be using JSON RPC either. That doesn't make sense. Cool. Did everyone get to Did anyone get to run some of the examples? Yeah. Cool. Sweet. Awesome. Yeah.
So before that, these relayers that kind of built on top of 0x, they had their own liquidity separate from each other, right? They had their own order books, and they were in the same orders on all of them.
So some of them were already sharing, but it was very ad hoc, right? It was like, I'm going to pull orders from Radar and maybe like Bamboo or like ERC DEX, but there wasn't. Exactly. Yeah. Yeah.
You all have like one shared kind of order book because you already own the network.
Yep.
All of them can now share.
Yeah. Exactly. So essentially, everyone is more liquid, but kind of what changes is, as a DEX, as someone who's building a relayer, your business model is no longer predicated around putting a moat around your liquidity and charging access to it, but rather, targeting X, like creating a market for X asset in Y market, and like being the best at that. Yeah.
I have a question. Sorry, maybe it's not very technical, but how does it work with NFT? Because like if I see the order book, it should show up as a asking price and as a size, but NFT is unique for each one.
Yeah, that's a really good question. So, and that's actually also part of the reason why we don't want to be too prescriptive with the querying language that we're giving people, because depending on whether you are querying NFTs or fungible tokens, you want different query parameters and ways of sorting and organizing the information. So at the end of the day, everything can be represented as these orders. So just where was it? I want to sell this for that at this price, and that information, right, is generic whether or not you're trading a non-fungible or a fungible token. What changes is how you want to organize that information and kind of query it. So the SRA, we built it when 0x only had support for ERC20, and then we had to also add support for NFTs, and it was already very hard to do that in a way that kind of made sense. So the way that I imagine things rolling out is there will be different APIs and kind of different databases that are going to be used for NFTs versus non-fungibles. Fungibles, sorry. Does that make sense?
Yeah, I mean, I would say that one thing is exchange, one thing is the marketplace. Because I faced the same problem, and my conclusion was that NFT shouldn't be in the exchange because it's a marketplace. It's like eBay.
Yeah, exactly, and that's exactly why we built two UIs and not one, because this doesn't work for NFTs, but this does. Yeah. Cool. Sweet. So that's all that I had prepared. It was a little bit faster than I thought. Obviously, the docs for Mesh are online. We have our GitHub where kind of a lot of the action happens, and we're always on Discord. So feel free to join us there and talk to us. And yeah, happy to answer any more questions about Mesh or just 0x in general.
Quick question. I'm not too familiar with LGB, sorry, but where is the data? So if I create an order now, or let's say I spin up an order, my browser fetches all the orders. Where is it persisted? Where is it stored? Is it like a shared database?
So it's going to be stored in IndexedDB in your browser. And IndexedDB,
Where do you fetch it from?
the orders from other mesh nodes.
Okay, so but they already have it stored on there.
Yes.
So some of them need to be online all the time.
Yes, exactly. And so I think it's the right type of incentive, right? If you have an order that you want to have on the order book, you need to have someone who's pinning it, so to speak, right? Like in IPFS. I think the people who will be running mesh nodes are relayers, market makers, like intense traders. For consumers like kind of us, yes, you can use a browser node, and I think that can be useful for kind of bootstrapping these early markets. But if you want your order to persist, that's kind of a service that a relayer can provide to you, right? So if you submit your order through a relayer, they will persist it even when you go offline.
Okay, so
does that make sense?
There's no like shared OpenDB database where you can just like query from like install an IPFS or something.
No.
Purely peer-to-peer and you.
Exactly. And I guess another point on that is that we're not trying to reach consensus about the state of the order book. So everyone will have a slightly different view of the order book. But that already kind of happens now depending on your latency and connection to even a centralized exchange. And two, you would take a really big performance hit if you were trying to like reach consensus at every stage. Yeah. Yeah.
What if my orders are similar in their logic to 0x, like they are signed off chain, I want to send them contract, but they're not abiding by the 0x format.
Mm.
Can I be able to build a mesh for them?
Yeah, so that's definitely part of our long-term plans is to genericize mesh so that it can be used for arbitrary orders. So like for us it would be interesting because we have different versions of the protocol. We'd like to keep one network running for V2 and then another one start another one for V3. But that could also then let other people who are not even building on 0x use mesh. So I would say today, no, right? We're trying to get something out the door, and so we're doing that. We're essentially making that happen faster by not worrying about making it generic. But in the future, yes, absolutely, you could do that. I think the hardest piece will be you will have to write your own validation logic, right, for your orders. Yeah, but we are adding that. We're adding a way for people to add custom validation on top of the base validation. But what you would need is like purely custom. But, sorry, once we do that though, we can make the base validation just be like part of a middleware stack of validation, and then you can just pull it out. So yes, there's absolutely a way to get there. And we'd love, if you're interested in kind of making that happen.
I'll give you my contact at the end.
Okay, cool, cool. Sweet. Any more questions? Awesome. Thanks so much for coming. I really appreciate it.